Welcome to T1 Academy. In our last sessions, we discussed about number system. So, in today's session, we will learn about LCM and HCF. LCM and HCF. Now, what is this LCM and HCF? Okay, we should know what is this LCM and HCF. Now, we all know very basic things. LCM means what? Least common multiple. Common multiple. When it comes to HCF, that is highest common factor. That means we will speak about the common factors. We speak about the common factors. So, common multiples and factors. What is meant by these multiples and factors? We will see now. See here, multiples. Multiples of a number are all those numbers which can be divided completely by the given number. That means, take for example, if you see 5, what are the multiples of 5? Nothing but the numbers which we usually see in the table of 5. So, 5, 10, 15, 20, 25, 30 like this. All the numbers are multiples of 5. For example, if I want to write the multiples of 6, what are the multiples of 6 do we have? 6, 12, 18, 24 like this. We will have these many multiples. So, for any number we will have infinite multiples. For any number we will have infinite multiples. Why? Because there will be no end for the multiples. We will have infinite multiples. Now, what is meant by these common multiples? When you compare 2 numbers or 3 numbers or 4 numbers, definitely few numbers will have the common multiples like, for example, we will take 2 and 3. What are the multiples of 2 and 3? 2, 4, 6, 8, 10, 12, 14, 16, 18 and so on are the multiples of 2, right? Next 3. What are the multiples of 3? 6, 9, 12, 15, 18, 21, 24 like this. These are the multiples of 3, right? If you observe carefully, there are some common multiples between 2 and 3. What are those common multiples? If you observe carefully, what we have? 6 and 8, 12 and 12, right? Next 18 and 18. Next, if you go in like this, you will have 24 and 24. Like this, we will have many common multiples between 2 and 3. Between 2 and 3. 2 and 3. So, this 6, 12, 18, 24 and so on. All these numbers are common multiples for 2 and 3. Common multiples for 2 and 3. Now, this is the things about common. See here, common multiples of 2 or more numbers are the numbers which can be exactly divided by each of the given number. For example, multiple of 3s I have written and multiples of 4 I have written here. Please observe here. And the common multiples of 3 and 4 are 12, 24 and so on, etc. That means 36 and so on, etc. Like this, we will have many common multiples between any 2 or more numbers. Okay, we will have infinite number of common multiples between any 2. But LCM means what? LCM is nothing but the least common multiple. Out of all those common multiples, we will pick the least one. So, the LCM of 2 and 3 becomes what? While writing the common multiples, what are the common multiples we have? 6, 12, 18, 24 and so on. Like this, we have many common multiples, right? Among all these common multiples, what is the least one? 6. So, the LCM of 2 and 3 is what? 6 for us. The LCM of 2 and 3 is 6 for us. So, in general, we will write in this manner. But if the numbers are very huge, usually we cannot write all these multiples and cross check it and all these things we cannot do. For that, we will take the help of prime numbers. For example, if I want to find the LCM of 2 numbers 120 and 150. Okay, so now what I will do? I will do the division method. By division method, we will try to get. So, 2 60s, 2 75s. Next 3 20s and 3 25s. Next 5 4s and 5 5s. Okay. Anyway, these two are co-prime set, so we will stop our process here itself. So now the LCM of these numbers becomes what? 2 into 3 into 5 into 4 into 5. Okay. So 2 3s are 6, 6 5s are 30, 34s are 120, 125s are 600. So the LCM of 120 and 150 is what for us here? 600. In this manner, we will find the LCM of any two or more numbers. For example, if there are three numbers, we will add that number and we will find the LCM of that number also. Okay. Next, HCF. We will speak about the factors. What are the factors we will have and how we will solve that one. A number may be made by multiplying two or more other numbers together. The number that are multiplied together are called as factors of the final number. We all know what are the factors for 12? 1, 2, 3, 4, 6 and 12. Okay, these are the factors for 12, and while discussing the number system also, we have spoken many things about these factors. That means how to find the factors, how to find the even factors, how to find the odd factors, prime factors, like this. We have discussed many things. So those are the factors. Now common factors similarly. See, for 12 and 18, there are many common factors, right? What are those? 1, 2, 3 and 6. These are the common factors for both 12 and 18. Okay. Now, the concept of co-primes was derived from this HCF only. That means if for any two numbers, if the HCF is 1, then we can say that those two numbers are co-primes. Okay. So, two or more numbers that do not have a common factor are known as co-prime. Do not have a common factor except one. Common factor except 1. See, usually for all the numbers 1 is a factor. There is no doubt in that. So, by default for any two numbers we will have one common factor. What is that one common factor? Is 1. So, we cannot say that there will be no common factors between any two numbers. Yes, there will be a common factor, and that common factor is also 1. So, if for any two numbers, if the HCF is 1, then we can say that those two numbers are co-primes to each other. Okay. It may be composite number or prime number. Anyway, the combination of prime numbers always will be co-prime pairs. And if out of those two numbers, if one number is a prime number, then also those two numbers becomes co-primes. Okay. Next, HCF. Just now we have seen. We will write the factors, how we have written the multiples, and we will choose the highest one among the given factors. Now see here, as I have already told you, for any number we will have infinite multiples, but we will have a finite number of factors. Finite means we can count the number for that given number. We can say that this number have this many factors, like that. Okay. Now, see the same thing for 120 and 150, I need to do I will take one more number, 180. 120, 150 and 180, I need to find the HCF. Now, what I will do? In 2 table, 260s, 275s, 290s. Next in 3 table, 320s, 325s, 330s. Next in 5 table, 5 4s, 5 5s and 5 6. Now see here students, in our previous case, even though if for example if this is, I will show you the difference between LCM and HCF. This is LCM. For time being, I will do the same thing for HCF. Okay, we will do the process is more or less the same thing, but at one point we will stop this one. This is HCF and this one is LCM. We will see what is the difference between them. So if it is LCM, please observe here. Here 4 and 6 are there and 5 is a prime number. But 4 and 6 are divisible by 2, so I can take 2. So 2 2s, 5s and 3s. So now I got all the prime numbers, right? I can do this process. I will multiply all these numbers and I will write my LCM. But in case of HCF, what happens here? Please observe here. 260s, 275s, 290s. Next 3 20s, 25s, 30s. Next 5, 4s, 5s and 6. Now, this is the major difference. In case of LCM, even though 5 is not divisible by 2, I can continue my process. Okay. But in case of in case of HCF, here 5 is not divisible by 2, right? So, I cannot continue my process. In case of HCF, all the numbers should be definitely divisible. Then only you should continue your process, otherwise you should stop your process there itself. So, here 4 and 5, 4, 5 and 6, all these 3 together are co-primes. All these 3 together are co-primes. Why? Because the common factor for all the 3 together is 1. Don't take 4 and 6. You should take all the 3. In this set, I have a prime number, right? So, obviously, their HCF will become 1 and they will become co-prime. So, I need to stop my process here itself and my HCF here becomes only 2 into 3 into 5. That is 30. 30 will be the HCF of these 3 numbers. When it comes to LCM, even though if one number is not divisible, we can continue our process and we can do the remaining things. So, this is the major thing which you need to observe between the LCM and HCF. Many of the students will get confused. What usually they will do is, they will, in case of HCF, we will multiply only these numbers. In case of LCM, we will multiply all these numbers. That is fine. But in the process also there is one change. What it is in case of LCM, even though if one number is not divisible, you can go forward. But in case of HCF, we cannot do that one. Okay. Next. Now here we have some standard formulas in this case. See here, the greatest number that will exactly divide x, y, z is HCF. That is nothing but HCF of those 3 numbers. Okay, next. The greatest number that will divide x, y and z. That means there is a number. It will divide x, y and z. See, a number dividing x, y, z means what? That number will be a factor for x, y, z. Okay. Leaving remainder a, b and c. That means if you are leaving remainder, for example, when 17 is divided by 5, what is the remainder you will get? 2. So, that means if you subtract 2 from 17, then obviously the resultant will be a multiple of 5. Okay, the resultant will be 15. For its factor will be what? 5. So, the same concept here also. There are some numbers. Okay, it will leave some reminders a, b and c when we divide with a number. So, for that we will find the HCF of x minus a, y minus b and z minus c. Next, the least number which is exactly divisible by x, y, z, that is nothing but LCM. We need to find the LCM of x, y and z. Next, the least number which when divided by x, y, z leaves the remainder a, b, c respectively are. So, what we will do is, in these cases remember one thing, always x minus a, y minus b and z minus c will be equal. Okay, and it will be equal to the value of r. So, simply you will find the remainder for, LCM for x, y, z and subtract that r from that one. Okay, next, the least number which when divided by x, y, z leaves the same remainder. See, in the previous case they are leaving different reminders, so we are subtracting them. But in this case it is leaving the same remainder, so we will add plus r to that one. We will find the LCM. And next, if x, y, z leave the same remainder in the HCF, here we will find the HCF of x minus y, y minus z and z minus x. That means the differences. We will simply find the differences HCF. Now we will see some of the problems based on this. Now please observe here. What is the smallest number which when increased by 5 is completely divisible by 8, 11 and 24? Now I need to find a smallest number which when increased by 5 is completely divisible by 8, 11. That means there is a number x. Okay, which when increased by 5. There is a number x which when increased by 5, it should be completely divisible by. That number is divisible by these numbers means obviously that number is a multiple of, that means LCM of 8, 11 and 24. The number will be obviously the LCM of C. Why? Because x plus y, 5 should be divisible by 8, 11 and 24. That means x plus 5 should be what? An LCM of x 8, 11 and 24. Now please find out what is the LCM of 8, 11 and 24. You can do the general process. No need to worry about this one. Okay. So 2, or else you can go with that remaining things also, 4 times, 11 times and 12 times, 2, 2, 11 and 6, 2, 1, 11 and 3. Okay. So now what I will get here? 8 11s, 88, 88 3s are 264. 264. So this is x plus 5. So now x will become what? 264 minus 5. So x value is 261. 261. That means now when I increase this 261 by 5, sorry, 259. What you will get here? 259. So when you increase this 259 by 5, it becomes what? 264. Then that 264 is exactly divisible by 8, 11 and 24. Okay. This same problem we can do with the help of options also. Usually what they will give is, they option something like this: 260, 264, 263 and 265. Like this they will give you some options, and always please verify the options from the smallest one. Sorry, 259 is the correct answer, right? So I will write 259 and 250. Assume the options are 250, 264, 263 and 259. Why we will verify it from the smallest number? Means in the question they clearly mentioned that is the smallest number. So what is the smallest number I have here? 250. So I will increase this 250 by 5. So what it becomes? 255. I will check whether this 8, 11 and 24 are dividing this 255 or not. Okay. So 255, is 255 divisible by 8? This is an odd number, right? Is odd number divisible by 8? No. So 255 is not my answer. Next option is 259. That means next least option. So 259 plus 5. What it becomes? 264. Now I will divide it with 8, 11 and 24 and observe the remainder. See, 264 by 8, yes, it is divisible. 264 by 11, it is divisible. 264 by 24, it is also divisible. So our answer becomes what here? 259. Our answer is here 259. In this way also you can do the answer. See, one is by the concept and the other one is by taking the help of options. You can follow any one of these two methods. Next one. Find the greatest number that will divide 148, 246 and 623, leaving the remainders 4, 6 and 11 respectively. But leaving the remainders means if you don't have that remainders, what you will do? It is exactly divisible, right? So the same thing. Here while dividing 148, it is leaving a remainder 144. That means 148 minus 4 is exactly divisible, right? Yes. Next, when I divide it with 246, I will get a remainder as 6. That means 246 minus 6, what it is? 240. That one is also exactly divisible. Yes. Next, when I divide it with 623, I will get a remainder as 11. That means 623 minus 11, that is 612. This is also exactly divisible. So these are the numbers I have. I need to find the HCF of these three numbers. So 144, 240 and 612. 612. See, it is up to you. You can go with the big numbers also if you are really good. Else go with the small numbers. Nothing wrong in that. So 272, 120, 306. Next, similarly 2, 36, 60, 153. Next, in 3 table, 3, 12, 20 and 31. 31 is a prime number, right? So our process stops here itself. Why? Because these 3 will become by default co-primes. So now 2 2s are 4, 4 3s are 12. So what is that highest number? This number will be nothing but 12. 12. So our answer here is 12. So here also the same thing. How we have done the previous one, option verification. Here also first of all subtract the remainders from that. You will get 3 numbers. Okay, and do the option verification. Okay. Find the greatest number that will divide 115, 149 and 183, leaving the remainders 3, 5, 7 respectively. Similar one to my previous question. So here what I will do? I will find the HCF of, I will write directly 112, 144 and 1 76. 112, 144, 176. 2 times 56, 72, 83. 56, 72 and 83. Okay. So, next in which table? Sorry ma, not 83, this is 88, my mistake, 88, right. So, once again in 2 table, 2 28s, 2 36, 2 44s. Next in 2 table, 2 14s, 2 18s, 2 22s. Next in 2 table, 7s, 9s and 11s. Our process stops here. So, what you will get here? 16. So, what you will get here? 16. 16. So, 16 is the greatest number that will divide. See, this is greatest number, right? While doing the option verification, please start verifying from the biggest number, okay, so that you will get the answer very quickly. Next one, find the greatest number that will divide 55, 127, 175 so as to leave the same remainder in each case. Earlier also we have seen the formulas in that slide. See, greatest number, if it is leaving the same remainder, then what we can do is we can simply find the HCF of their differences. We can simply find the HCF of their differences. So, we will apply the same concept here. Find the greatest number that will divide 55, 127 and 175. So, what I will do is I will simply find the HCF of 55 minus 127. We will not bother, we will only observe the difference. No need to worry about the signs. No need to worry about the signs, simply observe the difference. 127 minus 175 and 175 minus 55. What you are going to get here? HCF of 127 minus 55. What you will get here? 72. You get here 72. Okay. Next. 127 minus 75. What you will get the remainder here? If you consider this as 130, you will get 45 plus 3, 48. Okay, good, super. Next, 177 minus 55, you will get 120. And if you calculate the HCF of these 3 numbers, you will get the HCF as 24. 24. 24. Calculate it, you will get the HCF as 24. So, the greatest number that will divide 55, 127 and 175, so as to leave the same remainder in each case is nothing but 24. 24. Next one. The greatest number which will divide 410, 715, leaving the remainder as, leaving a remainder 7 in each case is the same thing, right. So, please try to get the answer for this one, everyone, and try to mention it in the comment section. We will see. Next one, 3 bells. Okay, this is one of the most important type of questions. Why? Because in more or less all the examinations, they will ask one question from this area. Okay. 3 bells chime at an interval of 18, 24 and 32 minutes respectively. At a certain time, they begin to chime together. What length of the time will elapse before they chime together again? So, that means nothing but they all will ring at the same time. Okay. Usually, it will ring for every 18 minutes, 24 minutes. And so, when we will get the common things, this process is nothing but our least common multiple only, right? Why? Because please see here. It will ring at 18 minutes, next second it will ring at 36 minutes, after 36, next it will ring after 54 minutes, next it will ring after 72 minutes, next it will ring after 90 minutes and so on, right? Right, next the same thing, the second one will ring after 24 minutes, next it will ring after 48 minutes, next 72 minutes, next 96 minutes, next 120 minutes and so on, right? Now, next when it comes to this one, it will ring after 32, 64, 96, 128 and so on, right. So, what length of the time will lapse before they chime together again? So, that means after how many minutes all the 3 will chime together. That means we need to write, see, if the first 2 bells are there, after 72 minutes they both will ring together. just after 72 minutes. But they are including the third bell also. So now please here, if you go on writing in this manner, it will take us a lot of time. Instead of that, the same process, where we will do the same process, we will do the same process to find the LCM. So nothing but for this type of questions, we need to find the LCMs. So LCM of 18, 24 and 32. You need to find the LCM of 18, 24 and 32. So what is the LCM of 18, 24 and 32 we have here? 18, 24 and 32. Please do that one. 9, 12, 16. Next 4 table. I will go with the 4 table. 9, 3 and 4. So next I will go with 3 table. 3, 1 and 2. Right. So 2 4s are 8, 8 3s are 24, 24 3s are 72, 72 2s are 144 minutes. That means after 144 minutes, they all will chime together. After 144 minutes, they all will chime together. Usually there will be different types of questions. This 144 minutes, they may also mention as 2 hours 24 minutes in the options. Any one of these two is correct. Sometimes they will say that they all rank together at 8 o'clock. That means at 8 a.m. When they all will chime together, they will ask us that time. In that cases, what you will do, 8 a.m. plus 2 hours 24 minutes. That means they all will chime together after how much time? 10 hours, 10 o'clock, 24 minutes. Why? Because they all will together chime after 2 hours 24 minutes. So 8 o'clock plus 10 hours 24 minutes, it becomes 2 hours 24 minutes for us. It becomes 2 hours 24 minutes for us. Right? This is part 1 of our LCM and HCF concept. Later in our next sessions, we will see the complete explanation of all the, we will see all the different types of questions. Even there is one more important concept under this LCM and HCF. We will discuss them in our next session. Thank you.